Hi, I'm Samantha from the IMWUT Human Lab at University of Auckland, New Zealand. I'm excited to present Prompto at Ubicom 2021. We most often face prospective memory lapses, forgetting to perform intended actions in the future, such as leaving items behind. We could address these lapses through memory training or mobile applications. However, these applications mainly provide time-based prompts to promote regular training. A well-timed prompt may not be effective if we are not cognitively available to engage in the training. In this work, we focus on providing prompts when users are cognitively available. We explore the notion that when we are calm and relaxed, we are potentially more receptive. Prompto was designed to detect a low cognitive load state through physiological signals of electrodermal activity, EDA, and heart rate variability, HRV. This is estimated to be when EDA values are low or near baseline and when HRV is increased. When this cognitive load state is inferred, it sends you a prompt which asks you to start a memory training session. In a training session, Prompto guides you to apply a memory technique to help you remember an intended task better. This technique is called implementation intentions, or the when-then technique, and is known to strengthen prospective memory. It involves two steps. First, to formulate and visualize a when-then sentence, such as, when I leave home after breakfast tomorrow, then I will bring the documents. And second, to visualize yourself performing the action. We demonstrate Prompto through this video.
Starting session. Tell me a task that you intend to do.
Check my emails.
All right. In what situation are you thinking about doing this?
Later this afternoon.
Good. In what location would you need to remember this?
At home.
Prompto guides you to form a when-then sentence.
When I arrive home, then I will open the computer to check my emails.
And asks you to confirm when you have visualized yourself performing your task at a given situation and location.
Done.
We conducted a study on older adults' receptivity to these prompts at low and high cognitive load conditions, giving them 4 prompts per condition. We mapped out their responses to these prompts, which could either be starting practice of the memory technique, asking it to try later, or ignoring it. We found that users started significantly more practice sessions in low cognitive load compared to high cognitive load. And there were significantly more responses to prompts in low cognitive load compared to high cognitive load. We also conducted a field deployment with older adults using Prompto for 7 days. This was to understand if the benefits of prompting at low cognitive load could still hold. It was also to identify the challenges and requirements to prompt based on physiological signals in the wild. Users received at most 2 prompts that were at least 5 hours apart. Although the response rates during deployment was lower than the response rates in the Receptivity Study, users were still likely to respond to its prompts and to start practice sessions. Most users appreciated the concept and found Prompto helpful. In terms of the wider implications of the work, there are other cognitive functions that rely on working memory and cognitive load, such as learning. We encourage more research on prompting based on cognitive states, developing systems that determine if you're in the right state of mind before you start an intensive task. We have shown through thorough exploration what is possible with and what is needed for sensing cognitive load states. Imagine what more is possible in combination with other contexts such as time and mobile usage activity. There are several limitations and future works. Different sensor placements and forms could be explored. There are, of course, many other methods for cognitive load detection. A noise filtering algorithm could be put in place to reduce motion artifacts. And lastly, there are known effects of age on physiological readings and different physiological readings for each person. Machine learning models could be implemented for more robust detection. To summarize, our main contributions are Prompto, a conversational system that measures physiological signals and prompts for memory training sessions during low cognitive load. A study on older adults' receptivity showing that users were significantly more responsive to prompts and engaged in more memory training sessions in low cognitive load compared to high cognitive load. And in the wild deployment, revealing that most users appreciated the concept, found Prompto helpful, and were likely to respond to its prompts. And here's my awesome team behind this project. We're looking forward to future collaborations related to this project and other projects. You can also check out the paper and our websites for more details. Feel free to contact us for further discussions, and I hope you enjoyed this presentation. Thank you.